computer. Are we recording? Ah, yeah, we're recording. Grand. So, welcome everybody to another Makerspace. So this is another in the series of our introductory Makerspaces catered for first-year students. Not being on campus sucks, so we're trying to get as much connection between first years as we can. The last one of these we did went really well and helped a lot of people. So we're doing another one. We're hoping to do more in semester 2 if they are needed. If we might be doing the same thing for second years as well with digital analog electronics. But for now, we're just getting towards first years, semester 1. So today we'll be doing experiment 11, light and sound. I'm not to believe that this is another full lab report, is it? For the
It is, yeah.
yeah. So you have to do the full series lab report. Introduction to electronics is great for learning how to write lab reports because, pardon me, myself and Aoife have like 5 lab reports in the next week and a half. So you will be writing a lot of them, especially if you're doing mechatronics. You'll be doing a fair amount. So getting in and learning how to do them with relatively easy to understand circuitry, while also understanding how components like transistors and capacitors actually work. You'll be going on to do more stuff with BJT transistors in second year with digital analog electronics. And if you do anything electronic, you'll be learning a lot about RLC circuits next year in circuits and then systems with Marissa Condon. Those modules are just like whatever you think you know about circuitry math, out of the window. It's all downhill from here. It's crazy. Some of the stuff you do in that module is unbelievable. So it took me a while to get this working. If y'all have the reels of cable that came in your first year electronics kits, like this one here, these here, these reels of cables are great for. I managed to find my first year electronics kit between the last Makerspace and now. So these are actually jumper cables that I made in first year. I made these 2 years ago and I kept them in the box. So if you see on the circuit diagram here, these red cables, these are dead handy just to hold on to because you will be needing them a lot to just like bridge, because you get in later modules, you get a lot of what are called Dupont cables. So I think I have one here. Yeah, so these are Dupont cables. So a lot of the time they have male and female connectors on either end, depending on what configuration they're set up in. They're dead handy for just like plugging straight into a breadboard, just like that. Like they don't snag, they don't get caught up in anything, and best of all, they don't short. So when I was doing this earlier on, a lot of the problems I was having, if you see, let me just go full screen with my video again. How do I go back to my? There we go. How do I full screen spotlight for everybody? So if you see here, these jumper cables here for the 5-volt line, and you have a few more here for carrying over ground signals between all the transistors. The ends of these are just raw metal, and same thing with these resistors, they're also raw metal. So if they knock off each other at all, unfortunately also the transistors in this, the transistors they gave me anyway, did they still give you these metal cap transistors, or have they given you plastic? Yeah, they conduct electricity. They will short out anything that they touch off of. So like if I don't want to do it in case it breaks, but like if I were to like accidentally knock like this capacitor slightly to the left, it'd short out against this resistor here, and then the whole thing would just go straight to ground, and the resistor, this flashing wouldn't be happening. So yeah, be careful of shorts. I have a wire snips somewhere. Oh, here it is. So the other thing is, like I said last week, did anybody manage to pick up a pair of wire cutters? Oh, the guy's got one.
Yep.
Yeah, we get them.
Yeah, these are a lifesaver. I have a pair of wire strips somewhere as well, but they've been lost in the move. So these are dead handy, especially with the first year kits, because you actually get to hold on to them. So like if you're doing these experiments and you feel that like excuse me, like I was saying with shorts earlier, these little resistors, the legs on these are massive, but you can cut them down to that way that they only are as long as you need them to be, and they'll be flush to the board. And not only does it make sure that you don't short your connections, it makes it easier to read, easier to photograph, easier to follow without a circuit diagram. So if you show this to somebody without the circuit diagram, if you have shorter leads, to be able to tell exactly what's going on. Also, you'll be doing it in semester 2 of this year when you're soldering for your car. You have to snip down all your resistor legs so all of them are even. So it is, lecturers do appreciate when you have everything snipped down. It makes it way easier to look at. Lab techs as well will appreciate it. So yeah, if you haven't already, I would recommend picking up a pair of these. Mine are ancient, so they're slightly rusted. Wire strips as well. Let me see if I can find my pair. Give me one sec. Okay. So again,
Yeah, we were Jake.
Yeah.
they actually gave you them in your case. So I remember, Aoife, do you remember in first year when we didn't have these?
Oh, I don't think we have.
Yeah,
We don't get wire strip.
No.
yeah.
We get wire cutters, not wire strippers.
So like if you have yeah, they're I think Aldi were selling them when I got mine. But like if you have your cable here, let me see if I can get a raw end of this cable. So you can strip this with a wire cutters, but like if you go too hard at all, it just snaps and breaks. But these are great because you can actually adjust them for different wire gauges. So like we had to strip the where's it gone now? The transformer.
Hey, Jacob.
Yep.
You're the one. That was you. You're on biting them off. We didn't have
Yes.
any of those yet. You're on
Yeah.
biting them off. I was like, what are you doing?
I got
See,
sick
someone came
in
out
the
and was like, wire
lab.
strippers.
Yes. Without these, I ended up having to bite the ends off these. Don't do that. Bad idea. Pro tip: don't bite wires. You good, Aoife?
Don't, you'll break your teeth. Why would you do that? Oh my
Because
god.
He did it.
These took, and I needed to take the ends off my wires. Don't at me. So yeah, pick up a pair of these if you want to keep your teeth. And a pair of these.
You also
Yeah, keep your teeth.
buy one of these.
Oh, those. What are they?
You know,
What is that?
it's a tiny little keychain version of what he was holding.
Oh,
And
cool.
it's
Cool. I wonder if you can 3D print that.
it costs like 50 cents. So
Okay, probably not worth it.
What is it?
it's like it's a wire
keychain
stripper,
wire
but
strip.
it's like a tiny version of that.
Oh, that's so handy. I want one. I want 10 actually now that I think of it.
It's yellow.
they're
I
very
like
cheap.
it.
So anyway, I will get back to the experiment. So if I share my screen, so here we go. I'll ignore my Spotify. So this is the components list, the one that's at the start of everything. I didn't end up being able to find, this kit is 2 years old, so I am short a 3.3 microfarad capacitor, and I am short my loudspeaker because I believe they come in the tool kits, don't they? Not in the actual like electronics kit. So I
No,
will
they
have to
come in-
get. They come in the
No,
same
we
one.
don't actually have a loudspeaker. We have like a piezo buzzer.
You have a buzzer?
Yeah.
Yeah.
One of
I
these
saw it
buzzers,
in
yeah.
mine. Yeah, I think we still have one somewhere. But yeah, I wasn't able to grab one of the. One of these. I only have one of these. I wasn't able to find my second one. So if you see in mine, I've used 10 microfarad capacitors. I could find all of them. So my one will flash slightly lower than yours if you're following the diagram that's in the book. So just for the record, this is what happened last time. Everybody can see this working, right?
Yeah.
And so if I tear it apart and it doesn't work, y'all know that I'm not a fraud. So I will now tear this apart and hope to God that it works the second time. So I will first of all plug it with cables. I will. This is actually painful. Like, oh no.
It's like Lego.
No,
believe in
it's
you.
like
Do it
Lego,
again.
but it can kill you.
Lego, but it can kill you.
Yeah, that's what building a PC is.
I know that all too well.
Yeah, I first built a PC and my PC blew up on me, like actually exploded. Nearly killed me.
My electronics kit blew up on me.
Oh, yeah.
I fried one of the Arduino clones we were given for a module this year.
Anyway.
Anyway, I have an Arduino, but
I really like half my LEDs.
Oh yeah, I think the
I-
first time when I was building this and it didn't work, it was because of a blown LED. That's the other thing. Do y'all have a multimeter actually?
Yeah.
So
Yeah.
so this I don't know. Can I see the multimeters that you were given? Are they the okay? So we
Mine
were
is the
given
old one that
these.
doesn't turn off.
Okay.
Nah, they're not that fancy.
Do you all have a setting on your multimeter that looks like a little Wi-Fi signal with a diode on it?
Some of us do and some of us don't.
That's continuity mode, isn't it?
Yeah.
Yeah, the
So
continuity one.
if your multimeter has, it took me way too long to think of this when I was doing it earlier on, but if your multimeter has continuity and you want to test when the LED is blown, does it work? There we go. So yeah, if you have a continuity mode on your multimeter and you know if an LED is blown, you can use that. So I just want to make sure. Oh. There we go. Y'all heard
Could you
that?
do it on camera, please?
Trying to see if it's working. It beeps.
It's just
Y'all heard it.
pushing the other. Just like,
Oh yeah,
Yeah.
USB.
well,
Ours doesn't. No, mine doesn't. Some do.
yeah, no, ours
Ah!
doesn't beep. We
Oh no,
give them
mine
ones with-
beeps.
Yeah,
Some-
the
yeah,
newer
some of
models
us-
beep. The older models don't.
Yeah, some were given some that beep and some.
Y'all heard a
aren't.
beep.
I,
The continuity mode.
We
on
we
your
did not
thing,
hear a beep.
yeah, I
but
didn't hear a beep.
We were
We didn't
only-
hear a beep, but we can trust you.
Yeah,
It
well,
beeped,
you
I
know,
swear. So
We saw the LED working. It's okay.
Yes.
Is the LED supposed to light up? It is, yeah.
It's not the flash.
yeah.
Okay.
So
I mean, yeah, an LED.
we were only told about the continuity mode this year. So you went through 2 years of electronic engineering not knowing what this was.
Oh
I
my
don't want to say
God.
that I don't want to say that that's our fault, but it kind of is. But anyway, we will now go along with following along with the. Can I make this slightly? Can I make my myself slightly bigger so I can record both of them? Ah,
I
perfect.
mean, you can do it for yourself, but everyone else has to do it.
So can y'all see my video beside the? Can y'all see my video like enlarged beside the circuit diagram?
Yep.
Yeah.
Oh, brilliant! Didn't think that worked. So I'm building it at 90 degrees flipped from the actual circuit, but hopefully you should be able to follow along. So the first thing we'll do is just pull over our. So using a 9-volt signal for this, I'm using my own battery cap because it just has better connections. The first time I did this today, wasn't working because my battery died. So make sure your batteries aren't dead. You can use a multimeter for that as well. So let me see here. So the first thing we're going to do is just take one of these smaller cables. If you all held on to them. By the way, if anybody has any questions, throw them in the chat. There's one there already.
Okay, that's like brown and black.
If I see the chat, where's it gone?
That's 10.
When
there
you're
it is.
sharing your screen, it's
They're giving someone their camera. Okay. So there it is. Okay. So yeah, if anybody has any questions, throw them in the chat. And if I miss them because I'm looking at the camera, then give a shout. So the first thing I'm going to do is just pull over a 9-volt signal. So these breadboards are like perfectly aligned, so you can see like they kind of match up pretty well. But these are slightly off kilter, but it should be okay. So we're just going to pull over by 1. Ideally, I'd make this a little bit shorter so it was flush to the board, but it should be okay. That's almost a tiny bit out of focus, but hopefully it's okay. So the next thing we're going to do is hook up one of our 4.7? 4.7K? Yeah, 4.7K resistors. So that is the there you go, yellow, purple, then red with a gold tolerance band. If you're all worried about being able to sight read resistor values, don't worry, I still can't. I never will. So we're just plugging this onto, I'm actually just going to move this over by 1, and we're just going to plug this into the same rail as our jumper cable, and we're going to go down and skip 4 rails and then plug it in. So we're going to plug it in right there. On my board, I'm plugging it into 53, the 23rd rail, but again, it's upside down. I'm actually going to cut that a tiny bit shorter. So because you're first year kids, you get to hold on to them, you can do this, but in digital analog, you don't get to hold on to them. So make sure you ask before you do it, but I'm just going to put these a little bit shorter and then plug it in. Like that. So you can already see compared to what it was the first time around, this is that's grand, Eva. I'll keep recording. So yeah, even just by putting this down even a tiny bit, it doesn't move. It's not like this happens. You get like bandy legs on the resistors, so it's impossible to actually, you try to put them in, the whole leg crumples like that. So putting them down makes it a lot easier. So
I'm sorry.
next, what's that?
Sorry.
All
Sorry.
right.
Yeah, what's the value of that resistor, please?
This one is, if you scroll down to the page below, it'll tell you that this is a 4.7K ohm resistor. So 4,700 ohms. It's yellow, purple, and red. No problem at all. So scroll back up. So next we're going. Oh, was there another question? All right. So next we're going to plug in one of our transistors. So I had a little window open up that made it a little bit easier to follow, but these are the types of 2N, 22A transistors that you've been given in the kits. So these you'll normally find two kinds of transistors. They'll be like hemispherical shape, sort of flat edge, or there'll be this cylindrical top with a tab on it. So if it has a tab on it, the tab is always over the emitter pin. Yeah, so it goes emitter, base, collector. So if you see on the circuit diagram, this is using the other form. That's the exact same thing. It's just emitter, base, collector, but it's just a little bit easier to track on these cylindrical cap transistors. So we're just going to be plugging that in with the emitter pin on the same rail as the end of our resistors. So just, oh wait, no, I got that wrong. Just like that there. I'm just pulling it a little bit off to the side just so that way it doesn't knock off the transistor here, because I was having problems with shorting earlier on with this type of transistor. So next up, we're just going to...
Sorry, just with the transistor, it's the tab goes away from the resistor. You just put in, is it? Or is the tab closest to the
tab is pointing towards the resistor. So if you... it's kind of...
That would have been wrong.
So
perfect.
There we go. So if you see there's the
Tab's the
leg...
output, so.
Yeah, the tab is on the emitters. That's the output. So we want that connected to the same rail as the resistor. So if you can see that there, just going to try and do this one-handed. I'll focus on this camera app and great. So just like again. There we go. So the tab there is pointing towards the resistor. That's a good way to put that. So there we go. Next, we're just going to bring over another 9 volt, another power rail. So using another jumper cable, we're just plugging that into our power rail, to the rail just below the collector pin of our transistor here. So I'm using a short breadboard, a half length. So all of these will be powered. If I power any location on this rail, every pin out on this power rail will be powered. If you have a double length breadboard, which I believe you were given, you'll have to put jumper cables if you're going between the two of them, and you might have to for the second part of this experiment. I'm not 100% sure. So I will just, all right. So next we will be plugging in another transistor. So let's grab that here now. So same thing. Base, sorry, emitter, base, collector. So we're going to be plugging that in, as you can see here, just on the same rail as that jumper cable we just plugged in, back bang in the middle. So just like that. So, can you all still hear me?
Yeah.
Yep.
Yeah, we can hear you.
So next we'll be plugging in, where is it gone now? Here it is. Believe this is a 100 kilo ohm resistor. So that's brown, black, then yellow with a gold tolerance band. Almost sure that you've been given the same ones that we've been given when I got this kit. Now that was a while ago, so I'm not 100% sure. So let me just give me one sec.
Sorry.
Yeah.
Second transistor that you put in, is it the collector pin that's going to the hookup wire?
No, it's
That's
the
connected
emitter
to-
pin. It's actually plugged in the same direction as the first transistor. So both of the tabs are pointing that way. They're both pointing
Yeah.
upwards and towards the transistor. So if you want to think about it, the tabs are on this top leg here. So the tab would be here, here, and then here. It's on the same for all of them.
Nice.
So all of the transistors will be pointing in the same direction. So now we're just going to take a 100 kilo ohm resistor and we're going to put that down again. Up. Got caught the battery wire. Look at that. Up. All right. So another thing, if you're doing the soldering for the car in semester 2, you'll be Dr. Mark if all your resistors aren't facing the same way. So it's a good force of habit to get into just to have all your resistors facing the same direction. So we're plugging this 100 kilo ohm resistor to the base pin of this transistor. That's the middle pin. And then, I haven't put your resistor lighter too long to do that. So just plugging that in there to the middle. Oh, get in, please. Be nice. There we go. And then the other leg is going to the emitter pin of the first transistor we put in. So that's in the middle of the second transistor, the top leg of the second transistor. There we go. So again, cutting the legs just makes it way easier to keep track. So next we will connect our capacitor. So y'all at home, if you're following this, and you should, because you have to write your lab report based off the numbers given to you in the book. At this point, you should be using these. So I'm not sure if they look the same for y'all, but mine are WEMA 3.3 microfarad capacitors. Y'all didn't hear that. So 3.3 microfarad capacitors. One of the steps in the lab report is it'll ask you to swap from this 3.3 microfarad capacitor to the 33 microfarad capacitor. Fortunately, I don't have them. So so it'll ask you to swap between the 3.3 to the 33 to analyze the change in flash speed. So the higher the capacitor value, the slower it'll the LED will flash because the capacitor has to charge up and then it'll release all of its energy. The full description for the circuit is later on in the manual. If we have time, I'll try and go over it. But you'll have to be using these 3.3 microfarad capacitors. I don't have a second one, so I will be using these 10 microfarad capacitors. If you want to swap between different capacitor values and talk about it in your lab report as well, just to show varying values for capacitance. So same thing with an LED. The longer leg is positive. So this was on about earlier on, where if your legs of your components are too long, they'll do this. They'll get all lumpy. So I'm actually just going to put this a little bit shorter. Oh no, did I cut that too short? Oh, now I don't know which one's positive. The silver on these electrolytic capacitors, the film band here is on the negative side. These 3.3 microfarad capacitors are dielectric and believe don't have any polarity. So yeah, if you see there on the circuit diagram, I'll just point that out on my screen. On the circuit diagram here, there's no polarity indicated, but if you scroll down a bit further, it'll ask you to use, keep going. It'll ask you to use a 220 microfarad electrolytic capacitor here, and that has a polarity. So when you're dealing with such a small capacitance, the component has no polarity, so you can plug it in whatever way you want. So I'm just going to plug this in like that. So we're plugging our capacitor, the one leg of our capacitor into the same rail as the emitter pin of our transistor. We're skipping one rail, and then we're plugging the positive end. All right. Next, we're going to be plugging in one of our 47k ohm resistors, 47 kilo ohms. So again, I'm just going to be putting this a little bit shorter. Resistors at this value have no polarity, so we can put this in whatever we want. But like I was saying earlier, our device keeping all your resistors facing the same way. So this one, so like all of my from my one here, all of my tolerance bands, these gold bands are facing down. So this 47k resistor is going to be plugged into the same rail as the pin of our capacitor, and then connected to the first rail with the jumper cable on it. So just like, well, that's what happens if your resistor lets you too long. They get all bendy. There we go. So does anybody have any questions so far? Or is this all good? Well, now. So we'll never be using another jumper cable. Oh, actually, I think I messed that one up. I'm actually just going to move this resistor one over, just so that way I have space for the jumper cable. So if I plug this, just legs of this thing again, they're all a bit long. Oh, put this in a bit too short. The same rail as the top end of our capacitor. And then the top rail with our first jumper cable. So just like that. Hopefully that should work. Now we're just going to plug a jumper cable in to connect both sides of the breadboard. So just like that, they carry over our 9-volt signal. Again, these could be caught a little bit more elegantly, but whatever. From here, we're going to work our way over, and we're going to plug in another of our 47 kilo ohm resistors. So again, tolerance bands facing towards the bottom of the circuit. So I'm just going to put this a little bit short. And plug it in with one leg going into the same rail as that jumper cable, and then we're skipping 2 rails and then plugging the resistor in, just like that. While we're here, we're going to do the same thing for our 4.7 kilo ohm resistor. So that's yellow, purple, red with the gold tolerance band. Going to bend the legs out on that. Put them a little bit shorter, not too short because this one has to go fairly long. Oh, missed the leg. So we're plugging one end of that into the same rail as that jumper cable here. So just like that. And then we're skipping, how many is that? 4? Yeah, we're skipping 4 rails of pins and then plugging that in there. So if some of you have noticed by now, I believe. Yeah, this part of this this resistor and capacitor set up here is symmetrical. So it's the same on one side as is on the other. I've lost my other capacitor. There it is. So now we're going to plug in our second capacitor. So again, if you have these 3.3 nanofarad microfarad capacitors, you don't need to worry about polarity, but I do. So I'm just going to make sure that the positive end, which is the end without this little film thing, is facing that way because that's being connected directly to our 9-volt signal. So when one end of the capacitor is going into the same rail as our 47 kilo ohm resistor, and then we're skipping one and then plugging it in. So here we go. So our capacitor, if you look here at the circuit diagram, is connecting to one end of this resistor and then the other end of this one. Next, we're going to plug in our last transistor. So this transistor is going the same way as the other ones, with just the tabs facing in that direction. So we're plugging this in here with the emitter pin on the same rail as the bottom end of our capacitor. So just like that. Then we are connecting all these two. Is it these two? Oh, did I mess up? Yes, I think I'm off. I think I skipped one too many pins somewhere. Ah, yes. This transistor actually has to move up by 1. Just like that. Brilliant. So now we're just going to ground the collector pins of both of these transistors here. So let me actually just realize that I didn't have my spotlight for everybody. Solo view, there we go. So the video feed should be a bit bigger for everybody now. So let's leave it like that. So we don't want to look at the circuit. Does anybody have any questions about the circuit? Right. So now we're just getting another one of our jumper cables, and we're just connecting the collector pin of this directly to ground. So we're just plugging cable in there, and then the cable into our ground rail here. We have a transistor, and we're going from the back of this transistor, and we're just bridging the breadboard just like we did at the top. It's going up or down any pins, so that we're grounding. Do I have anything narrower than my fingers? I have a don't know where this came. We're grounding all of this one here. So this goes this pin over through this cable along this rail directly to ground. So that we're grounding the collector pins of both these transistors. So we have to do now. Oh, yes, last of all, not last of all, but we're just going to ground our last transistor down here. So we'll be using these brown, black, and red transistors. So this is a value 1K. So there's a 1 kilo ohm resistor. So we will just lift that down a little bit. And when we're, again, like I was saying, all your resistors, you want them to face the same way. All your vertical resistors, you want to face the same way, and all your horizontal resistors, you want to face the same way. This is our only horizontal resistor, so we can put it whatever way we want, but we're just going to put it like that. So we're plugging in to the same rail as the collector pin of this transistor, and then we're just going to plug that into any rail really on the other end. It's just to connect directly to our LED. So plug that into the breadboard. Like that. That one's a bit nasty. So plug it in. Next we have our LED. So again, the longer leg is the positive side. So that's this one here. I'm just going to bend that a bit. Plug one end into the rail with that 1K resistor, and the other end directly to ground. And now I actually remember doing this from the first time I did this experiment. This little cross hatch of wiring here, this one here, was a nightmare. So like it's a nightmare for shorts and stuff. So we're just going to take another one of our jumper cables, and we're going to connect the rail with the base pins of both transistors to the rail of the top pin of each of our capacitors. So for example, if I bend this cable back, you'll see in here, that pin there is the rail with the collector, with the base of this transistor. We're then going to be taking this jumper cable, and we're going to be connecting it to the same rail as, let me just move this resistor over a bit. We're going to be plugging it into the same rail as the end of this capacitor. So that's just there. This bit of the circuit can get a bit tight, get a bit squeaky, but I'm actually just going to take out this resistor here, and I'm just going to cut it a little bit shorter. Y'all don't have to do this if you did it right the first time, unlike me. So, maybe a little bit shorter. And again, just putting that back where it went. Does anybody have any questions about anything to do with the circuit at the minute?
How fast is the light supposed to be switching? Because I think I have it done, but it's going fairly fast. Like
once every second, should be on for a second and off for a second with your set.
No. No. Okay, something's on.
If you
Mine's
wanna,
just consistently on.
It's
so
on,
that
but
way,
it's weird.
if it's
I got
on, if it's on, but it's consistently on, you might have a short. So you can ask Aoife. She's not here at the minute, but she should be back soon enough. We were having a meeting earlier on. Just real quick, I'm going to connect this same jumper cable, another jumper cable here, just to finish this crosshatch in the middle. from the pin with the base of this transistor to the rail with the top pin of this capacitor. So that's this one, right? Oh, I knocked my camera around. Oh, technical difficulties. Yep. So I think that's, I don't want to say it'll work, but we can try. So now we're just going to supply 9 volts. If you want to get fancy, you can hook this up to one of your single pole, single throw switches and just have like a test thing. Save yourself having to plug in and plug out the wire every time, or the battery every time. We are going to plug this in and pray. Oh, it works. So I have 10 nanofarad capacitors. So mine will turn on once every, according to this, the book says once every second, on for a second, then off for a second with your capacitor values. But so mine should be 3 times faster because the capacitor values are 3 times higher. But mine seems to be turning off for a second, then on for a second. Yeah, if you see here, apply power, the LED should flash on for approximately 1 second and then off for approximately 1 second. So does anybody have any problems with the circuit? Has anybody gotten to this point? If so, do they just, I can spotlight their camera if they want to show. Anybody have any problems with theirs?
What's going on if your light is constantly flashing?
Constantly flashing.
Yeah.
How fast? Like really fast?
Yeah, fairly fast, yeah.
Evan, you had the same result, didn't you? Didn't you say yours was on really fast? I think this on for a second, off for a second might be a bit generous, to be honest. Like mine is on for a second, off for a second, and that's 10 microfarads. You only have 3.3 microfarads. So it's going to be hard to time, but is it flashing 3 times a second?
A lot more.
Do you want to share your video of the circuit? I can have a look.
Well, I can try lift it up to the camera if you want.
Yeah, if you don't mind. Yeah, you don't have to if you want to push her. Go on. This is what. See, last time it was grand. It worked. Ooh, fancy breadboard.
Can you see that?
Let me just have one quick look. I nearly made your host, bro. So let me just. So if you want to just bring it down, I mean, that's fine with me. I mean, it's flashing. Like it might not.
Yeah.
Like, it might not flash. Maybe the resistor values people put in are different to the ones in the book. Resistor values might do it. Did your resistor values there, Dara, are they 47K? Sorry, 4.7, 47, 47, 4.7, or are they different values?
Yeah, they're all the right ones.
In the book, they do use 2N2222 resistors. These are 2N2222A transistors. Doesn't make that much of a difference, but that is a difference. They'd be flashing faster due to the lower capacitance. So if I were to swap these out for the, I have these Bonker 1000 microfarad capacitors here. It will flash once every 10 seconds, thereabout. Not 470,000. Oh, so it is. Oh, jeez. It's 470,000. Oh, thanks, Joe. I've been saying that wrong the whole time. These are 470,000. I am using 470,000 resistors, but I've just been calling them 47,000 because I'm done with bricks and it's a Monday. So I haven't used the right ones. Just make sure everyone that you're doing it, they are yellow, purple, then yellow again. But yeah, flashing. Tell you what, we'll actually try it with. Do you all have these 100 microfarad capacitors? Sorry, 10. Do you all have these 10 microfarad capacitors? They'll look like this. Yeah, swap it out. Swap out. If anyone has it working and theirs is flashing really fast, swap out. Now, just make sure. These are polarized. So the longer leg is the positive leg. It's like an LED. So these electrolytic ones are polarized. So if anybody's is flashing really fast, swap out your capacitor values and then see what the story is. Is anybody's just not working at all?
Yeah.
All right, what's the story?
Yeah, same.
So is it constantly on or is it just not on at all?
Constantly on.
Constantly on?
Yeah,
That
same.
yeah, so that happened to me earlier. That could be a short. So you just want to go through look really closely at all the jumper wires, all of your component connections, and just make sure that I'll show you now. Actually, watch if I. Oh, that can work. If I like. Let's see if I can do this now without doing myself. No, I've done it too well. It doesn't work. No. Sometimes if some of your, you know the way I was saying, like if you plug in a resistor and the legs go all bendy, they go all like bendy. They might actually not make full contact, and if they don't make full contact, then it won't treat them as components. It'll bypass them completely. So if you actually look at the circuit diagram, if those resistors aren't plugged in properly, they will just be bypassed due to the fact that the signal can still make its way to ground eventually. So have the least resistance and all that. So just make sure all your resistors are the right value, actually inserted and not just like bending inside the board. It's happened to me before where I've had a resistor snap on me inside the board and not know. So I was doing an experiment. Resistor snapped in the board, didn't notice, then went to plug a resistor into the same one, squished the snapped pin into the breadboard and blew the hole. You can blow these. It shorted like the pins in here. So every time I tried to use that pin, it just didn't work at all. So make sure that just have a look inside the pin if you think that might be it. Dara, Evan, any news on using the 100 microfarad ones? Does anybody else have 10 microfarads or 100 microfarads? I'm using 10 microfarads. You can use 100 microfarads. It must be really, really slow. Again, part of your lab report is using different capacitor values at this point to analyze the effects.
I got it walking. But the thing now is it stays constant, but it goes Vita and Demo. If you can see, it stays on, but it does flash for a second, off a second, but it stays on. Like, unless that's just a short.
You know what? It is a short because mine just shorted. It stopped working altogether. Happens every time. But yeah, like just like me messing around with it, I think I shorted one of my components, and now the whole thing has blown itself.
And just after doing the exact thing, like the exact thing that you're just talking about with bending it inside of it.
Yeah, and it doesn't go in the hallway. Oh,
yeah,
this is
it's
like
not. It's like not even coming out.
Oh,
there we go.
Oh, there we go. Got it. Yeah.
That was fucking bad. Okay.
Everything's so close together to use the fucking pliers to reach anything.
Yeah, especially because if you look at the next part of the.
Oh, I can't wait for the next part.
Yeah, oh no, I just have like fucking sausage fingers, so like it's just tough anyway.
Yeah, so actually what just happened there is that my LED wasn't connected properly, so it wasn't working. All I did was reseat the LED and it worked. So as well, you're right as well. Actually, I think mine is slightly on.
Yeah.
A little bit, even when it's not on. No, I know it's 100% off. Are you using 10 or 100 microfarads?
I am using 10 at the minute now. I swapped them out.
The same's happening. Helen, is yours constantly on, or is it staying on even when it's flashing off?
Yeah, when it's flashing off, there's still a bit of light left.
But at least we're consistent in our failure, so there's something wrong.
Yeah.
That's lab report material right there. Yeah. Reproducible errors are still results.
I swapped the LED for a buzzer because it doesn't appear on the camera. Want to hear it?
Fuck yeah.
That actually doesn't sound that bad. That sounds way better than I thought.
Sounds pretty cool.
Yeah. Impossible phone looking head out. All right. There we go. So yeah, my LED contacts are just super weird. So if I just tap off it, it might stop working. Wait. There we go. Yeah. So sometimes your component's going to be weak. Again, all this is experimental error, and you know they gave you fancy breadboards this year. So yeah, it could just be once if you the circuit diagram there. I was on this for about an hour. from like 1 to 2 o'clock. Just it was constantly on. I just kept moving around all the components. So
Yeah, that's enough of that.
yeah. I just kept moving around the components. So reseating the LED, if you have a snips or even a scissors will do for the resistors, cut down the resistors so that way that they're not touching off each other. Make sure that the jumper cables aren't shorting one another either. So has anybody else gotten theirs working or lack thereof?
I'm still at the same point.
It's probably
Same.
yeah, it's probably something along the lines of a short. So it did happen. I was on it for about an hour, but I was actually on the meeting with Aoife, and I just stopped looking at it, and then took the meeting, and I looked back at it about 10 minutes later, and it was working. The switchboard would say, "Yeah, I have to go get this circuit working." Oh, it's working. So, what do you mean it's working? So we just start working. So I thought maybe it was something to do with my capacitor values being wrong, but that doesn't. There's my flash. Oh no way! I literally go to show it and it stopped working. Read it here. Actually, just all stop. Hold on. Anybody else got any progress? Yeah, mine's just gone kaput completely. So, well, actually, we're on this journey together then. Put a bunch of components around, like as weird as it sounds, just start like moving stuff. So just like move wires and stuff. If the LED flashes on, you're doing something right or wrong. Did I put this in backwards? You see your battery?
The count if I just keep pressing the button on and off. That's flashing. I attached the button so that I could like test it.
Well, so once you let go of the button, it stops turning on. It's only on when you're supplying power to it, is it?
It was more of a joke. I'm not
No,
actually
but
sure.
what I'm saying is that if it is on
Yeah,
when
no,
you're
like
supplying
the
power,
way I have it is.
because that means it's most likely a capacitor.
Supplying power.
Yeah, I think that's most likely I think it's most likely a capacitor short then, like by due to some capacitor incompatibility or like, you know. Oh, remember what I said about my resistor snapping? That just happened. Jumper cable just completely shorn and stuck inside the board. So
oh no.
Nice.
got it. Oh, got it. Here we go. Like pulling out winter. So let's see, what time is it? 6. So do people want to stick around and try and fix the problems on this, or do we want to move on to the second part of the experiment? It's up to yourselves. We can stick on this for the whole thing and try and get this one working, so that way you have one proper working, or you can kind of use this as a baseline, and then we move on to the second one, so you have a baseline for both. I don't know how to do a poll in Zoom. That's useless. Normally Aoife do that, but right, I'm using my teeth again. No one tell Aoife. Ow. Go. So I'm just going to see if I replace my jumper cable. If that does anything, please do.
No, but I did the resistor thing again.
It's all bendy. I mean, this is good. Like, it's good best practice, you know, to have the means to mess up and have a bunch of people around to tell you why or how or perhaps maybe how it's all messed up. I tried using a blue LED to be fancy, but
Ooh.
you know, I don't know. Those are super high power sometimes.
Honestly, I'm super tempted just to take everything out and do it again.
It has worked for me. I did that with this. The transformer wasn't working, so I unwound this. This is 60 turns of 33 gauge wire. So it's like about 4 times as thick as a hair.
Dan, you did
Flashing
it.
on and
I'm
off
so
because
proud.
Wait.
it's flashing on and off.
Yeah, everybody, that's
Awesome.
flashing, right? We'll all back them up. Peer review. It's flashing.
Oh gosh. Okay, yeah. I have to take
All right.
everything apart.
Yeah, so I mean, taking it apart and putting it back together again, like that's what I'm saying. This is what happened to me earlier on, where it was just completely fine and then stopped. Getting 7 microvolts between power and this LED. It's this cable. I'm convinced it's this cable. All right, let me get a Dupont.
Actually, that's a good idea. I'll test it before I take it apart.
Nothing. Like last time, we all saw it working at least once. So, first of all, we'll test to see if we have power going between the rails. We don't. Is my battery cap shorted?
I took the resistor out. Oh shit, where did I put the resistor?
Overload. Yeah, so when I have my multimeter on the power and ground rail, I'm getting no notable voltage between the two. So it could be my battery cap. Let me replace this. Hold on. I mean, the battery cap is just soldered together somehow.
Which way do the capacitors go? Is it positive goes up
Positive
in the
goes
diagram?
up. Yeah, the positive
Gotcha.
will go up because it's be connected directly to the 9-volt signal from the power rail.
Yeah. Okay.
The
Let's see.
they gave me these little yokes, didn't they? These little battery cables.
What is wrong with you?
Why can't you just be normal? Oh, it's working again. It was my battery cap. So yeah, I replaced it with the old battery cap from my first year kit and it worked. So yeah, it really could be anything. Like a lot of the time your circuit will be working, your circuit will be right, but it could be something small. Like I've had breadboards go, oh, actually, yeah, another one. The car for Project Contact Drawing, you have to make it turn. You have to make it do 5 laps up and down of a line. This just stopped working again. And it wasn't working for us. And my teammate Steven was like, take out the cables and flip them. No, it was turning the wrong way. It was meant to be turning left, it was turning right. I was like, take out the cables and flip them. I'm like, no, that won't be it. Like they're labeled left and right. And he's like, no, do it, trust me. We did it. The IR sensors were bought directly from a factory and then shipped to the school. They were soldered backwards in the factory.
I think I have it.
Wasn't working. Oh, it's working.
But okay, so hear me out. So do you know the way when you have a battery, you lose voltage? So most batteries aren't actually 9 volts, they're like 7-ish.
Yeah.
I just reduced the voltage down to 7 on my little, the plug. Works perfectly. On for a second, off for a second.
So, oh wait, you're using the variable AC to DC power supplies that they gave you in the kit, did they? They put them on our toolkit. We never used them. We just used 9-volt batteries. So maybe
I know, mine died, so it's in my multimeter, so I have to use this. So maybe that was it. Because now it doesn't stay on at all. It's flashing on now, off, on, off.
What was the original setting of that 9 transformer?
It was 9, and
9?
I moved it down to 7, and it's working now.
What capacitors were you using?
I'm using the 10 ones now. I'm going to swap them out for the 3.3.
How much voltage should be going through the like last transistor?
Find out.
How much voltage should be going through the last transistor?
I'll check the collector base voltage now. I just don't want to mark off my battery cap.
Oh, Jesus, that's
Getting-
flashing like it's having a seizure.
I'm getting 640 microvolts.
Okay, there's my problem.
Yeah, I'm getting 640 microvolts between the base and the collector of this transistor. And it's going up, down, up, down, up, down, up, down as this capacitor recharges and discharges. The voltage across the LED is circulating between a minimum of around 300 microvolts and a maximum of about 1700 microvolts. So if your LED is showing a constant voltage, that's due to a capacitor short. So this capacitor, Lee may kill me for this, but this it's a AC voltage where it's like it is like it's a theoretical, not even, but you know, it's up and down, up and down, up and down, up and down. This isn't an AC to DC converter circuit, but it's kind of it should be showing you an alternating voltage, but due to the card rate of the capacitor. So I think you did time constants. We did time constants last time we did one of these, didn't we?
I think so.
Yeah, it'd be that calculation. You might have to do a similar calculation in your lab report. 100% sure. So
Did we do time constants? Oh no, we did, because I remember my graph was arseways. Put it in the write up. Got full marks somehow.
Oh, love to see it. You really do. I got 4 out of 10 on a lab report once, disputed it, and I went up to 10.
What? Very much.
Jesus.
Yeah, I don't know how. I didn't.
Oh shit! Of course, there's not gonna be any value. I don't have the power connected. I'm fucking idiot.
Yeah, I did the exact same thing.
Why is it 0?
I forgot to push down my button, so it wasn't
No
working. I was like, why am I getting no voltage?
All right. Anybody else? Any updates, questions, problems, queries?
You fix mine.
Question, yeah. And so you see
The
how
questions have to be about this.
What you're saying, Jake?
You see how there's a 100k resistor coming from the left capacitor, and that's failure.
Yeah, this one here.
If we were to do that on the right side also and copy like the transistor and the LED, would they be alternating then?
I think so. You might need another one of these. You would like if this the top bit, like this bit, is symmetrical, but again, it's this little bit here flashing the LED. So yeah, if you were to put another, why bother to try that?
Oh, it was in ohms.
You gotta work. How do you have this working?
That is not how to measure.
I was checking the voltage in ohms.
I mean, you could find that. That's one way.
If you want to make it really awkward on yourself, then go ahead.
I'm getting 1 volt across the LED.
I got what you were saying, but only one of the range. Like I wasn't getting the full range of it. I was just getting if it wants to. Oh yeah, I have to push the button.
I'm a little bit closer.
Get rid of this damn button. This button is causing more problems than a solution.
1730 milliamps.
Yeah.
Millivolts.
That's what I got across my LED.
Yeah,
So-
but I'm only getting the 1730. I'm not getting like the range that you were saying.
I think so. Try reseeding your capacitors.
Okay.
So while y'all are working on that, I'm gonna try.
Milliamps.
Oh, I need to check the chat. Sorry. What?
I'm getting 1900 milliamps.
Yep, they all are within theoretical error. Every time you add a resistor, there's a 10%. That tolerance on your resistors adds up. So yeah, every time you add a resistor, the change in theoretical and experimental values goes up by 5%. Sorry, like the potential difference between theoretical and experimental values goes up for every component due to component instability and at really, really low values, stuff like EMI and like environmental stuff.
So there's a 30% gradient in this, is that?
Oh, I'm after solving my problem.
Did you fix it?
Yeah, I was just a dumbass.
Oh. What happened?
It turns out that I didn't do like half of the fucking circuit.
Ah, right.
Actually, I did that last week.
Do it.
Did that last week. Somehow got it to work. Don't ask me how. And yeah, just got ticked off and left.
Yeah, this works. Yeah. Yep. All right. I'm a dip. I'm a head out. All right. Right.
What was it we said? We used the wrong formula but got the right answer. Just said that. We just kept saying that.
That is engineering mechanics in a nutshell. You do statics next semester, all, and yeah, I was not very good at that.
Oh, why did you stop?
I mean, fixed and it doesn't even work.
No, Jesus, what's going on?
What's my 220 on? 220. Has anybody else gotten it working? Helen, any updates?
Fixed.
I broke it differently, if that helps.
Yeah, I fixed mine. One of the capacitors was the wrong way.
Brilliant.
Awesome. Lucky. Help.
Oh, capacitors the wrong way. Could that be an issue?
Yeah, the one furthest to the right.
The one farthest to the right. Okay.
What way should that be facing?
Wrong way.
The
pin should be facing bottom right. I think.
Oh.
I turned it around and it worked.
Fair enough.
Wait.
That wouldn't affect it though, because in the what is?
It would affect it, but I mean, like, what?
Why? Yeah.
If you have
because they're all
electrolytic
facing.
capacitor. No, if you're using an electrolytic capacitor, they have a polarity, so it would affect it.
Oh, sorry, capacitor. I thought you meant. I thought you said transistor. I was like, why?
Yeah.
That's.
Well, if you have that the wrong way, it would affect it. If you have the transistor the wrong way.
I turned the transistor around. I was like, wait, why is this not?
If you had the transistor the wrong way around, it affected it as well, though, because you'd have the emitter and the collector.
Yeah, exactly. That's why I was kind of like,
all transistors are facing to the left.
The right way around.
All to the left. They're not moving because I don't want a little poof.
I don't want a poof.
It would work. So I'm trying to do the next part here, where you swap out the 1K. Oh, these resistor values are way too high.
Wait a minute. No, that's right. Never mind.
These are 47K. I was using 470K.
Wait, should that be coming from the? Yeah, that should be coming from there. I'm just an idiot.
I'm a little bit close.
Oh. Yeah, look, they alternate.
So big and
so
strong.
You're in the wrong place.
How did you do that?
Oh, look how chunky.
Okay, so I mean, it's flashing. I got it flashing.
Flash.
But it's not even. It's like pulsating.
Yeah, this one's flashing. Mine's still
Jack,
glowing.
how did you do that?
Jake, what?
Jake just casually showing off.
Jake just showing off the fact that he can do electronic. Like mine is.
Oh, is it?
Mine is just like flickering.
Oh, okay.
It's not.
I'm trying to get it working now, but I can't find the resistors that I need.
Switch the capacitors to a smaller value, and it might.
To a smaller value.
Yeah.
Is that it, or is there a second? There's a second part. It is super fast. Okay.
Yeah. Mine is like seizure inducing.
Yeah, no, basically mine's going like blah, 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 blah. It's like a fucking
what
hard
value are you
sugar
using?
rush.
What value are you using?
3.3.
3.3.
I think Darren's earlier on was going mad fast at 3.3 as well.
I feel like we have the exact same thing going on here.
I got mine turning on and off.
Do you
it's
replace
going
them
like
both?
really slow.
What
Like
capacitor value are you using?
The 10, the black one.
Is it every
It turns
second?
off. It turns off for like 2 seconds and then turns on for like 2 seconds.
Whatever.
Yeah, that's what happens with the 10. And if you switch it to the 3.3, it goes like it's going 90.
Wait, 10 micro.
Oh, she's going 90, boys.
The 10 micro one, yeah?
Yeah, 10 micro.
My little hand 50, she's rapid and she's nifty.
You replace both of them, don't you?
Yeah.
And which way do you face them?
The longer one to the left.
There is a second
The
part.
thing is, I've been doing this from top to bottom.
But,
So
I think we're just going to try.
The longer one towards the battery.
Longer one
Well,
towards the back. Grand.
I think for anyone that's wondering, there is a second part of this experiment. I'm going to try, there's 3 parts technically. There's this, and then if you are looking at the diagram, there's another one where you basically just add another one of these, and instead of an LED, you have a speaker. You just add another one of these circuits below. So once you get the first one working, theoretically, you can get the second one working, no problem, and then just replace the LED with a speaker. It mentions stuff about high and low pass filters here, coupling capacitors. So again, all the theory and stuff you'll have to go through yourself.
That is not.
But yeah, if you have the first part of the experiment done, you can basically duplicate that setup and the main part of it, and then use it to complete the second part of the experiment. So I'm just trying to see, where did it go now? I don't actually have the resistor values for the third. Yeah, this interim part here where you make it pulse. I know Jake had it working. I'm trying to get it working myself, but I can't find the right resistor values. There's one. So yeah, if you don't have any questions about the first part, you'll probably be grand to continue on by yourself. You can use the first part again, just literally copy paste it down with some extra jumper cables. It does warn you to change your capacitor values to be way smaller in the copy pasted version. So when you're creating the second part of the circuit, just make sure that your values for capacitance are way smaller. But yeah, if you have any questions about the first part, then you should be able to wrap it up. Again, read back through the theory. I am by no means a lecturer, but I recommend reading through the theory. The Make Electronics has great theory sections just for explaining how everything works correctly without bogging you down with a bunch of weird maths. So, any updates on any of them?
Should it be turning fully off?
Yes, that's the problem that Evan had. His wasn't turning fully off. How did you fix that, Ev?
I put it down to 7 volts, and then it kind of worked.
So just put less.
Wait,
just
Dan,
let's
which
go.
are your-
It's just reducing how
It's a
much you put into it.
solution. It's a solution.
Check which way your transistors are facing.
They all are facing.
All tabs to the left. That's what I have.
Yeah, all tabs to the left.
If you switch the one furthest to the right and switch that tab to the right, it made mine flash slower. Or like that made the light turn on and off.
You swapped the transistor all the way. Okay.
Yeah, like I just did a 180 and then it fixed it.
But like, don't they like blow up if it's wrong?
Yeah.
9 volts to be fine.
It
I
didn't
know,
happen
but
to me, so.
No, now mine's just completely on.
Oh, is it? Okay, don't do that
Mine
then,
just
Evan.
stayed on.
Anybody else
I
saw
think that's
that?
the right way. Yeah.
Anybody else saw transistors cooking?
Jacob, is it grand if it like turns on for 4 seconds and then turns off for 4 seconds?
What's your value of capacitor?
The small black one.
Is it 10 or 100? Because they're both the same size.
The 10.
4 seconds is a lot.
Yeah, no, mine's the exact same capacitor and it doesn't go on that long. Like mine's basically mine's on and then more on and then less on again. Like it's changing how much light it's producing. But
I
it's not
have
going
an
to.
idea. I don't know if it's going to work, but I have an idea.
I found it. All right, find a second resistor so I can do this last part here.
My
So,
little hand.
yeah, we'll probably leave the second part of the experiment to yourselves, just because it's just a carbon copy. So it should be all right. So
This goes. What is the thing? Yeah, it is.
See, the fuck. Oh god! Oh my
hey,
god!
the pulse works.
I thought.
Oh shit! Why'd you? Oh, hold on now. Oh wait, yeah, no, that's because I have a 10 micro ohm. That's why. Never mind.
Is it going fast?
Little excitement. Oh, I'm sorry.
I thought I blew up my computer for a second. It just turned off the screen.
Oh, oh, that happened to me
My
when I
screen
spilled
auto
a
turns
pint
off
on it,
after
and
like
I just
5
panic.
minutes. Like I literally just moved a capacitor or something like that, and I thought I blew up my computer. I was like,
Is it
this
connected to
isn't
the computer?
connected to my computer, but I thought I blew
I was
it
gonna
up.
say.
Wait, what's connected
There's
to your computer?
no connection
Nothing.
between the two whatsoever, but I
Oh,
thought for
it's just
some reason,
that moment. Yeah.
like it was the moment I moved a capacitor that it was like turned
Oh
off,
God.
nothing's connected, what's wrong?
What happens if I
Everything's
put
wrong.
it down to 6 volts?
We have to connect these to our computers for electromechanical systems.
Please
or
don't
the
break.
part of it. And
Aren't you lucky that you have a choice, Evan?
Well, who was that
he's
choice?
You.
Sorry, I was gone.
For what?
The choice of voltage.
Oh yeah, just gonna flex on you.
Yeah, I literally just have my battery.
Don't you
So-
also
Do you not
have
have
don't you also have the transformer?
What transformer? What?
This, the plug.
Oh.
oh,
hey.
Oh, for fuck's sake.
Fuck is this?
I didn't even know what that was. I just left it.
The variable AC to DC converter.
Oh, here,
I-
but this would actually be connected to my computer then.
Is it not a plug or is it USB?
It's a plug, but I mean,
Connected to the
Yeah, but they
surge
have-
protection. You got RCDs, you'll be fine.
Yeah, you know what? Yeah. Yeah. Probably should have plugged out my computer, but
I'm gonna go across my room to use my other plug.
Anyone else got anything?
well,
Or
smallest violin for you there,
questions
Dan.
or anything
No,
working?
I'm
or
not
lack
gonna change.
thereof?
I'm not gonna use the battery, the thing. I'm gonna figure it out with 9 volts.
Yes, probably
You
for the
do
best
properly.
because all the
Should
maths.
I order a pizza?
Because then I'm not just copying it. What?
Should I order
No
a
problem,
pizza?
Sheriff.
Can you order it to my house?
Should I though?
If it's to his
Yeah.
house, yes.
If it's to
Your
my house,
no.
yeah.
Free pizza. Oh, that's another thing you're missing out on. We get free pizza all the time.
Yeah, so I've been here for an hour and a half and I ain't even gotten the LED turned on, so that's great.
Oh.
Right. Do you have a camera?
Yeah, I do. Yeah, I'll turn it on.
let's-
Yeah.
let's
I don't
hear it.
understand what's going on. Right. So can I ask a question first?
Yes.
What capacitors are you guys using?
10
10.
micro.
My ones are red.
10 micro.
You're
Red,
using 10
that's fine.
micro.
Yeah,
10
we're
micro,
using
yeah.
10 micro just because that's what I'm using. But the lab manual does ask you to use these 3.3.
Yeah.
Yeah.
It's just
Well,
not
the
working.
3.3
It's
is
not
just
even
going like,
powering on. Like,
So
so I'm
the
gonna
LED
show
is
it to you.
Make sure you turn off your background because it interferes a little bit.
Oh, you're right. Yeah, hang on, give me a second.
He turns off his background and he's actually just on a Star Destroyer.
I wish.
That's like
no.
5 walls.
All right, hang on, I'm coming back now. I'm trying to get this thing to do. All right, yeah, so, okay, I don't know if you can see that. No, you definitely can't see that. Let me turn the lamp off. Like,
So
I just
let me-
don't understand what I'm doing wrong. Like, let me see if I can pan it down. Maybe does that look better?
Let me have a look.
There we go.
Take a picture and send it to us on Discord or something. It'd probably be handier.
Yeah.
Yeah, I just don't understand what I'm doing wrong because it's not even powering on. Like,
So I will say is that like the try and keeping your circuits small makes it more difficult to work with, but way easier to track. So like,
yeah,
that's the size of my circuit. You know, that's with the pulsation at the end. So like the Dupont cables. So we'll start from the start. So like the same thing that works for everyone else was just make sure that none of your components are shorted. Make sure that none of the little resistor legs are touching off any of the. Using Dupont cables is a good idea though because it means that you don't have jumper shorts. Like I was shorting mine between my jumper cables as well, like along these. So if you don't have that, then
so like basically make sure the metal isn't touching the actual resistor.
Yeah, make sure that no metal is touching off each other at all. Like I had problems with the transistor caps. The transistor caps were knocking off each other. The
Oh, I see. Yeah.
Yeah, if any of those metal parts are touching, it'll short and go straight to ground. So that is the problem with these 2N, 23, 22A transistors is that they're metal capped. And if they're metal capped, like it's just a nightmare because
You just insulate everything.
yeah, like the ones in the make electronics are plastic, like because this is a nightmare. Like
Sorry.
you good? Okay, I thought you were just popping off because I thought you got working. Are you good? We had a guy.
No.
We were doing an exam, and somebody really messed up the exam and just like swore at the top of his lungs into the mic. And I'm like, bro, your mic's on. And he's like,
That's not even exams for us. That's just normal class.
What value do I have on this? I have a webcam, but I don't know what value this is. 7.5 volts. Okay.
Sure.
We'll try it. We'll try it on 9.
Try it on 9.
Oh, God.
You're gonna have a lot more like 9 volts in this battery is like 9 volts, like end of story. But 9 volts out of those things can be a bit noisy.
Yeah. This is staying on, but going dimmer and brighter.
Yeah, that's what I have.
That's fine because if yours is coming, are you using the plug, Daniel?
Plug.
No, I'm not using plug. I'm using 9 volt.
All right.
I'm using
yours
plug.
Is staying on. Okay. What could possibly stay on? For me, it was shorts. It was just shorts between components that would cause it to stay on. So
that's a fucking dumb idea. Use a metal screwdriver to check if there's shorts while it was on. While it was on.
That's why I have a button.
Yeah.
But I can't make that dumb mistake of holding down a button and checking everything.
What is that shorting? I'm just gonna move it out the way.
Love these things. It's big fucking.
Oh god.
Hey Jacob.
Yeah, bro.
Is that okay?
That's the 3.3, is it? Is that using 3.3 microfarads?
10 microfarads.
Yeah, I mean, if it's flashing, it's flashing. Like, the reasons why it might be flashing faster or slower could be like anything really. Like, depending on how close your components are, probably shouldn't be flashing that fast, but it is flashing. So you don't get mad fancy with your lab reports and just say that it did flash. And they're like, if they go to sign off on it tomorrow and it doesn't work, if they say that's too slow, then maybe have a look at it. But for the minute, like you have, like even having it flashing, even if it's flashing too fast, is a good baseline. Having just this first part done means that you're already 3/4 of the way through the lab tomorrow, you know, so you can fly through and finish it. So
what do we actually have to do for the last part then?
So the last part, so I did the interim part there. There's like a middle part where it asks you to like do pulses instead of like, you know, if you look there, see the way mine's going, it's like breathing. That's this part. If you look at the thing, the lab manual, if you look at Make Electronics, it asks you to replace the 1K resistor straight to ground to the LED with this series of resistors and this electrolytic capacitor to ground. This causes the I'm not, well, again, don't want to say anything about the theory in case I'm hilariously wrong, but this basically just makes it pulse instead of flash. So that's the middle part. Then there's another part there at the end where you have to take this pulse part out, put the 1K back in, and then basically clone the circuit. So you just do the same thing again. So the exact, if you look at Make Electronics, it's the exact same. The only addition is that as opposed to having the jumper cable coming across, you just have it coming down. And these ones labeled B are just to join the two ends of this double length breadboard. Other than that, it's the exact same. This 1K resistor goes to ground through this jumper cable instead of an LED, and there's an additional capacitor here. Otherwise, it's just a duplicate circuit. It does warn you to use smaller capacitors for the second part. So that'd be these 1 microfarad capacitors, which I believe are these teeny tiny ones right here, these little white ones. So yeah, once you have the first part of it working, you should be able to get the second part, no problem. Any luck, Aaron and or
Absolutely none. It's just, I don't know. I'll figure it out tonight.
Yeah, it's best thing, part apart, chuck it back together.
Yeah, that's what I'm doing at the moment.
It's a nightmare, but taking everything apart, like I had to take the oscilloscope apart twice. So take
like one thing I don't get as well, like when I put the wire almost half, this is the wire connecting the battery to the breadboard on the left rail. When I put the wire in, but don't put it in all the way, it does what it's supposed to do.
That could be a faulty connection on the rail.
Yeah,
could
I don't
be-
know what's going on there. 'cause that doesn't
Try
make a whole lot of sense.
when you're putting the battery cable back in when you rebuild it. Try putting it in a different place or shortening your battery cable, because what you could be doing there is that you could be pushing the battery cable from one pin under the board to the next and shorting it.
Yeah,
That could
maybe.
be that might be what's happening.
But does that happen? Because I mean, some of these components are quite close together, so that doesn't make like. How would that work then? Surely everything would be shorted if it could go from one pin to the next. No.
Again, probably like it's just if it is minor things like that are causing a difference. Like I just there, mine stopped working. I just swapped out my battery cap and it started working again. Why?
Yeah, I'll try that.
Yeah, I swapped out my battery. Now I think you only get one, which sucks. But you can use a bit of blue tack and a Dupont cable as a battery cap. Technically, it's nasty, but it works. Same thing with any of the other components. Swap them out. You have a good few spare. I think you have one spare transistor. So for the full setup. So if you do the full setup and it doesn't work, try swapping out some of the resistors. Try swapping out some of the transistors. If you're in the lab, have a look at other people's ones. See if their circuit is different to yours. Try and keep everything small and close together. It does make it a nightmare for shorts. But it does make it way easier to follow. Like if a lab tech comes up, like I remember I'd have the alligator clips, like I'd have them coming out of the board like in a big rat's nest, and like I'm not even gonna look at that until that's gone. I'm like, that's fair. Like it's nasty, but yeah, that's fair. So like keeping everything close together makes it way easier for somebody to have a look and actually see what the story is.
Yeah.
If anybody doesn't get it or does get it, throw videos or questions or anything you have in the Makerspace channel on the Discord. If you're not in the Discord, you'll have to become a member of the Engineering Society to gain access, just because like we can't be sharing the data of non-members. So if you want to gain access to the Discord, just sign up to be a part of the Engineering Society. It's £2 for the year. It's normally $4. But if you sign up there, the link to our Discord is there, and then there's a Makerspace channel. So through that channel, you can ask questions about any of the Makerspaces we've done or any of your experiments. The Discord is handy in the way that if you ask in your core, I'm gonna guess y'all have a course group chat, yeah? Like is there a first year? Yeah. If you ask in the group chat and like nobody has any idea, if you ask in the Discord, somebody might, because you have second years, third years, and I think there's a few fourth years and a few postgrads. So like everyone who's not a first year who's in the Discord did the same thing at some point. So everybody's been through the same stuff. They don't change a whole lot of the modules. They haven't changed any recently anyway. So like somebody will be able to help you out if you need a hand at anything. That goes for
I think I
personal
actually forgot to follow that link to the Discord.
It's on the, if you go to DCU, I think it's under DCU Life now. Wait, if you go to DCU Life, no, sorry, it's DCU Clubs and Societies. That's what it is. Actually, I got the link now. DCU Clubs and Societies. It's just the hub platform for all of the clubs and societies you can sign up for. Even though we're not on campus, I highly recommend that you join a bunch of clubs and societies. They do the clubs and societies night, the award ceremony at the end of every year.
I put the link in the chat for the engineering one.
She's back. Jesus. Back for the sole purpose of chilling the society. I love to see it.
Yes.
Hey, Jacob.
Yeah.
I think I got it like right.
that.
I don't know. I think it's right.
Perfect.
These were.
Yeah, that looks good. That's exactly what mine looks like. If you're using the 10 microfarad one, that's exactly what mine looks like.
Yeah.
In terms of the flash. Yeah. What did you do to make a flash lower?
Swapped the 10 microfarad one around like the legs of it.
Oh, it was in reverse, was it?
Yeah.
There we go. Grand. So,
Just wondering, what way did you have it facing? Because I'm after taking the entire thing apart, but I don't want to make the same mistake.
If you're looking at the 10 microfarad capacitor and one part of it has this kind of gray film on the outside, that's the negative side. So
Not be facing down, yeah.
Yeah, the both negative side should be facing down. So you should have the positive end facing up because the top legs of these are being connected directly to these resistors over to our 9-volt signal. So
I wish you said that before I took it all apart.
Right, that could be what the issue was.
I don't know why this is not working, but I don't care anymore. I'm hungry.
Food, the great decider. Am I going to keep working on this?
I eat.
I shall eat.
I'm thinking
We
pizza.
have a few new people joining the Discord. Hello, everybody.
Oh God, is someone else having pizza? I'm having pizza as well.
I'm thinking about pizza. I'm thinking.
Oh, well, I'm having pizza.
Oh, shit,
there's the
okay.
Discord.
that's
Okay,
so
I've been
loud,
looking
Jake.
like
Oh my
all
God.
over the place for the fucking link.
The Discord link?
Yeah, I was looking all over the shop for it, and I just found it there.
Ah, right. Oh, wait, no. Oh, you can't see the committee portal. Oh. There's like, no, I'm trying to close it, but it just keeps on opening it again. There's like passwords and shit. You'll be able to join it if you become a member of the committee. Ooh.
Jacob,
Yeah.
I have it kind of working. The LED is just constantly on, and I'm not sure. I'm using the 10 microfarad capacitor.
So, like I was saying to Dan there, if you're using the 10 microfarads, just for the record, for the lab report, do use the 3.3 because that's what's
Problem with 3.3 though is the pins are so short.
They are really short. That's why you use the 10 because the 3.3
They're so short. Like they just keep wiggling out.
Yeah, so that's why I'm using the 10. It's just easier. But for the purpose of the lab report, either say to the lab tech when they're signing off that you use the 10K because the 3.3 sucks, or mention it in your lab report that you use 10K just like for personal preference. Like it is just the same, like because one of the things it asks you to do is go from 3.3 to 33. You can go from 10 to 100. You have 100 microfarad capacitors, so you should be fine. If your LED is constantly on, Tom, it could be due to your capacitor's polarity being inverted. So this little gray film should be pointing down.
Yeah, I have them both down.
Brilliant. Okay. Keep look for component shorts. So like if your resistor legs are touching off each other, or if any of the resistor legs are touching off the top caps of these transistors, the whole thing will short back to ground. Make sure that all of the wires are just in the correct location. Sometimes a wire can just be off by a single pin. That happened to me before, and I didn't notice until the lecturer looked at it, so it looked like an idiot. That was great. That didn't go well. But
okay, let's see.
Yeah, so just keep an eye out for all your component shorts. Again, I know Jake put a video of his one up with the buzzer, so if anyone gets it working, they want to throw it up either to help out a fellow engineer or to flex. Both are valid reasons.
We all know Jake did it just to flex.
Yeah,
Jake.
Yeah,
100%.
Love that.
The laugh says it all.
Will they sign us off if? Will they sign us off if we have a flashing? Yeah.
If you explain to them why, well, they'll sign off the first part because there's 3 parts. There's flash, pulse, and then the speaker. So or buzzer, I guess. So like I have it on the pulse now, which is just swapping out the 1K with 2 more resistors with an electrolytic.
Oh, Adonis. No, that's innovation.
So yeah, you can explain to them why you chose to use 10 microfarad capacitors. Like the larger value means that you have less chance of like an error due to components. The legs are too short, so you couldn't get it working properly. The 10 microfarad capacitor looks cool because it does. So once you explain to them why you didn't use exactly 3.3, they should be okay with it. They might be like, nah, use the 3.3. It's just as easy as swapping out the capacitor and it should still work. Once you get it working with 10K, once you get working with the 10 microfarad, it should work with any capacitor. The higher the capacitor, the longer it takes, because the time constant increases. Again, for any of the theory, check out the Make Electronics book. It's really good. I'll try and get a version emailed out to all of the EngSoc members. So if you're not a member of EngSoc, again, I would recommend signing up because we're cool, I swear.
You're missing out.
You are missing out on movie nights, and we played Among Us there a few weeks ago. I couldn't make it, but it was hype. We watched.
That was fun.
We watched Spider-Verse, didn't we?
Yeah.
That was my recommendation, by the way. Just like that.
I was hoping for John Wick. I haven't seen him.
Yeah, John Wick's a good one. They were all heaters.
Yeah,
they're all just really good recommendation.
Yeah.
John Wick's class. And But yeah, like we do that kind of stuff all the time. With some of the stuff we did on campus last year that we can't do this year. We did beer pong. They don't like us talking about that one, but we did.
Oh, I'm so good at beer pong. I actually won a little medal.
We did beer pong. We did football. We did basketball. We did a scavenger hunt. What else we do? We do a big project every year. So this year's big project is currently in development. I'll keep it secret.
Is it a trebuchet?
It's not a trebuchet. That'd be fucking hype, but no, it's not a trebuchet. Aoife, can we build a trebuchet?
That would be fun.
Now you want a trebuchet, Jacob, don't you?
Yeah.
What?
Can we build a trebuchet?
Let me Google what that is.
Oh no.
No,
Trust us. I wouldn't lie to you, Aoife. We can do it.
Therefore, the answer is no.
I say yeah.
Yeah. See, the funny thing is that I guarantee you that we probably could build them, which is terrifying.
Yeah, do it and then do it on the mall, you know?
Use it on the physicists. For some reason, there's a microwave between us.
Oh my god, yeah. Do like a trebuchet, like you know, thing with like science and health or something.
That was one of the competitions I wanted to do. One of the competitions I wanted to do was a bottle rocket tournament. But then COVID hit. I wanted to launch bottle rockets with our community micros on them, so you could tell how high everybody's went.
Oh, that'd be good.
You bought and everything. And a lot of committee are off on internships in March, so we will not be able to rerun. So I implore you to run for committee positions if you so wish. It's great crack. You just get to meet a bunch of people. A lot of my mates. I know a lot of people outside of engineering that I wouldn't have met if I wasn't doing clubs and society stuff. You get to work with a lot of great organizations. I've worked with a bunch of charities and stuff. So yeah, if a position comes up or at the AGM in March, we'll be rerunning every position. So a lot of them will be good for grabs. So yeah, great.
And even by joining one society, you don't end up only joining one society because you end up meeting so many other people just from being a part of clubs and socks in general.
Yeah. You also become members of a society without actually becoming a member, if that makes any sense. Like you just go to all their events, but you never actually remember. Like I went to a bunch of TSOC events last year. Not a member of TSOC. I should be. TSOC are great. But
actually, what's that one you were telling me about, Dan, with all the fogs?
Oh, New Opportunities.
New Op.
Yeah, New Op.
Great.
Yeah, New Op are great. Alternative music. Did we do something with them last week, or are we yet to do something with them? Aoife, I can't remember. Have I had like a sieve?
Pretty sure we already did something. Or
yeah, did New Op do something with Ames, Daniel? I actually can't remember.
I only joined them last week, so
okay.
I know that they didn't do anything with Ames last week.
Maybe we haven't.
Maybe we're planning on doing something.
Maybe
I join all these societies.
Join alternative music. I'm not biased, I swear.
Okay, what's your argument?
Join engineering.
We're already in our engineering.
Me and Aoife are committee members of Ames.
Yeah.
Oh, okay. Cool.
Yeah.
And what's your argument for me to join?
Do you like music?
Shit's got me there.
Yeah.
What an argument!
You have a reason.
Yeah.
Do you listen?
Yeah, like that's it. I joined because I'm their sound technician. I actually don't listen to. I'm tone deaf. I don't play anything. Like it's, yeah, like you don't have to play anything.
And you own two guitars.
I own two guitars.
I own a keyboard.
But I'm playing and hope that it sounds correct.
Yeah, that's 100 gex, right? That's what that is. That annoys me. But yeah, you don't have to be like, again, you don't have to be particularly interested fully, or like Ames is not like you don't have to be mad into your music to kind of like be a part of it. Like I've got more into music as a result of being on committee. I was one of the founding members of the committee about 2 years ago. I can't run for the same position twice. But
Jacob, are you still recording?
Yes, I am.
Okay.
Sorry. How do I stop?
Oh my god, but it stays on. Okay.